If you've ever tried to build a multi-step AI application, you've probably hit a wall where a single prompt just isn't enough. You need tools, memory, branching logic, and maybe even multiple agents talking to each other. That's exactly the space where LangChain and CrewAI live, but they solve the problem from completely different angles. Today we're going to pull both frameworks apart at the architectural level, look at how they actually structure work under the hood, and figure out when each one earns a place in your stack. Let's start with LangChain, because it's the older and broader of the two. At its core, LangChain is a composition framework. The foundational abstraction is the runnable, an interface that represents any unit of work that takes an input and produces an output. Prompts, models, retrievers, parsers, and even your own custom functions all implement this same interface. Because they share that contract, you can wire them together with the pipe operator using what's called the LangChain expression language, or LCL. So a chain like prompt piped into model piped into output parser isn't just syntactic sugar. It builds a directed graph of runnables that supports streaming, batching, and async execution for free. The key mental model for LangChain is that you are the orchestrator. You decide the control flow explicitly. If you want a retrieval-augmented generation pipeline, you compose a retriever, stuff the documents into a prompt template, call the model, and parse the result. When you need genuine cycles and conditional branching, you reach for LangGraph, which models your application as a state machine. You define nodes as functions, edges as transitions, and a shared state object that flows between them. This gives you fine-grained control over loops, human-in-the-loop checkpoints, and persistence, which matters a lot when an agent might need to retry a failed tool call 3 times before moving on. CrewAI takes a fundamentally different stance. Instead of asking you to compose primitives, it asks you to describe a team. The core abstractions are agents, tasks, and the crew that binds them. Each agent is defined declaratively with a role, a goal, and a backstory, plus a set of tools it's allowed to use. You write something like, "You are a senior market analyst whose goal is to identify emerging trends," and that natural language identity actually shapes how the underlying model behaves. Tasks describe discrete pieces of work with expected outputs, and you assign them to agents. The orchestration in CrewAI happens through processes. In a sequential process, tasks run one after another, and the output of one task becomes context for the next. In a hierarchical process, CrewAI spins up a manager agent that delegates tasks to worker agents, evaluates their results, and decides what happens next. That delegation is the interesting architectural piece, because the framework itself is handling the routing decisions that you'd have to code by hand in LangGraph. The trade-off is clear. You gain speed and readability, but you give up some of that explicit, deterministic control. So how do you choose? Think about where you want the complexity to live. LangChain and LangGraph push control into your code, which is ideal when you need predictable, auditable, production-grade pipelines with custom logic at every step. CrewAI pushes control into agent collaboration, which shines for rapid prototyping and problems that genuinely decompose into specialized roles working together. They're not mutually exclusive either. CrewAI can use LangChain tools and models underneath, so you can mix and match. Here's the practical takeaway. If your problem is essentially a known sequence of transformations, lean toward LangChain's explicit composition. If your problem feels like it needs a small team improvising toward a goal, give CrewAI a serious look. Understand the abstractions, and the right tool becomes obvious. If this breakdown helped, subscribe for more deep dives, and I'll see you in the next one.